Alrighty guys, thank you so much for tuning in to our first episode of Magic in Action. So this is our first pilot episode of our new series, which will be going over all the magic we find on the internet. This will be videos that we find hidden between the crevices, and then we'll be validating the magic or telling you whether or not it is fraud. So today my co-host Chad has a fantabulous video to start us off with. Now I haven't seen it yet, but he tells me it is the immaculate representation of levitation. So let's go ahead and take a look, guys. Yeah, that was pretty rad. Chat, yeah, no, it totally is fine. No, yeah. Look at it, zoom, just across that floor. Oh my god, beautiful, immaculate. Have you ever heard of physics? Wonderful. We just love it. Love magicians. How do you think they did it? Of Newton's first law, maybe? No. Whoa, dude. So you mean that's like, what would you say, physics? What? I thought Newton was a candy bar. Alright, let's take a look here, because this is totally not levitation. So let's get started on this. Let's take a look into the validity of this magic here. Alright, Chad, let's start from the top. Newton's first law states that an object with no forces, no forces acting on it, if it's at rest, it will stay at rest, meaning it ain't gonna budge. Likewise, if it's moving, it's gonna keep on moving, just in a straight line at a constant speed, as long as there's no forces acting upon it. Look at this. So we got this heavy box, it's 50 kilograms. We got it on a frictionless surface, so it's covered in ice, no friction whatsoever. It is not moving, it's not budging, it's just chilling here. And then we push here, it starts moving at a speed of about 18.1 meters per second. We keep giving it another push, keep it moving. That box is going to keep at a constant speed at whatever speed it gets to. Once we put a force on it, keep pushing it up until we stop it. See, we stop this dang box. It is not going to stop by itself. It is going to keep going up until we stop it. It's the same idea that whenever we have a car crash. Speaking of car crashes, we got this nice man. Oh, look at that. Oh, look. And keep a couple things, and there he goes, ladies and gentlemen. Let's take a look at another view here. So this gentleman's driving with clearly no seatbelt on. Can't speak for the man. But he's going to be traveling at the same speed as the bus that he's sitting in. They're both going to travel forwards at whatever velocity that they're traveling in up until this bus makes impact with that wall, car, whatever it is that you see that make impact with. Then this man's going to go flying, because he's going to keep moving, because unfortunately him and the bus are not the same object. Same concept with our beloved skateboard and this candle here. So we can actually figure out the velocity of the skateboard and the candle by plotting the position versus time. So doing that for the skateboard and the candle, we're able to figure out that their velocity is 1.992 meters per second. And then once we take that string and board from moving anymore, that candle kept on going, and we continued to track that motion. That candle actually continued on with a velocity of 1.852. So what this ended up showing is it proved our concept of Newton's first law. The candle stayed in motion once that skateboard stopped. The candle actually kept its continued constant speed there. It just slowed down a little bit there, most likely because of the friction from the traction on the skateboard. Long story short, Newton's laws, first one specifically, no magic here. Wow, dude, that was pretty rad. So what you're saying is I'm totally right. It's definitely magic. Sure, Chad. Have fun.